time to put our factoring skills to use as we solve polynomial equations. Biggest thing as we look forward to solving equations here, we are going to need a factor. Sorry, spoiler. But also we want to make sure that we use this zero product property. And I can't emphasize this enough, right? So what we need to see is that when in our factoring, we need it to be, factor 1 times factor 2 is equal to 0. Then we set each factor equal to 0 independently and solve. That's what the zero product property is saying, okay? And really want to emphasize that you have to have 0. You have to have it equal to 0, not a different number. So, for example, here in our first one that we see, 3m minus 2 times the quantity 2m plus 1 equals 0, right? We clearly have that equals 0 behavior, and we have it already factored, so this one is actually a little more straightforward than most. We can set each factor equal to 0 independently and solve. So we'd have 3m minus 2 equals 0, or 2m plus 1 is equal to 0, and solve. So plus 3 or plus 2, right, gives us 3m equals 2, m is equal to 2/3, or solving this one, 2m is equal to negative 1, divide by 2, m is equal to negative 1/2. And we love fractions, yes, yes. Okay, there we go. Next one, so now here you might be tempted, okay, I'm going to do this in red to say don't do this, right? If you look at the left-hand side, you say, oh, there's a c in common, and you can do 2c minus 5 is equal to 3, right? And then you can do, c is equal to 3, and 2c minus 5 is equal to 3. Okay, this is wrong. Do not do this, okay? The reason zero product property works is because the right-hand side of the equation is 0. This one is 3. Okay, the property doesn't apply, all right? So what can we do instead? Well, move the 3 over, 2c squared minus 5c is equal, or minus 3 equals 0, okay? And now we need to factor. This one happens to factor 2c and then c, and let's see, let's put minus 3 here, plus 1 here. Okay, so I'm doing guess and check, okay? I'm doing guess and check for this one, so let's just confirm by checking. So 2c squared, as I distribute, minus 6c plus 1c minus 3. Yep, that's going to give me the minus 5c in the middle. Okay, so I checked. All right, now set each factor equals 0 independently. 2c plus 1 equals 0. c minus 3 is equal to 0. Solve. So 2c is equal to negative 1, c is equal to negative 1/2, or move 3 to the other side, c is equal to 3. There we go. Okay, so note on that. So this next one, right, same sort of trap as the previous one. It is equal to 8. I can't set each one equal to 8 independently, so I need to move it over and make sure it's equal to 0, right? K plus 1, k minus 1, minus 8 is equal to 0. Okay, that's fine and well. Don't know what to do. Answer? Well, we kind of need to, right, it doesn't factor, it's kind of factored, but not really factored. So what do I need to do? I actually need to, like, FOIL it out, do the distribution, and then refactor. Okay, if I do this, this should give me k squared minus 1. I'll let you confirm that. Minus 8 is equal to 0. So this is k squared minus 9 is equal to 0. And now technically here you don't need to factor, but move the 9 over, square root. Remember, plus and minus. But to emphasize factoring, I'm going to factor this as k minus 3, k plus 3. This is using a special form, right? Set each one equal to 0 independently. K minus 3 equals 0, or k plus 3 equals 0, k is equal to 3, or k is equal to negative 3. Okay? All right, last equation. In instances where you have expressions on both sides of the equal sign, right, we want to get it so that we have 0 on one side of the equation, right? So we need to move everything over. 8x cubed, move the 24 over, it becomes negative 24x squared. Move the 18x over, plus 18x equals 0. Okay, now what do? This isn't a trinomial because, well, it is a trinomial, but it's not a square, right? So let's try looking at this. Oh, there's x's and everything, and they're all even, right? So I think I can pull out a GCF of 2x, and then I'd be left with, oops, 4, right? 4x squared minus 12x plus 9 equals 0. Okay, and that looks a lot like 2x all squared, and then this 9 is 3 squared, and this, let's see, this 12 is 2 times 2 times 3. So this is actually another special factoring form of 2x minus 3 quantity squared is equal to 0. Okay, and so what I can do, right, I technically have three things here, but the zero product property still applies as long as you have a bunch of things all equals or all multiplying together to give you 0. Just set each of them equal to 0 independently. So 2x would equal 0, and 2x minus 3 squared is equal to 0. Okay, divide by 2, x is equal to 0. Here you would get, so that's one answer. Square root both sides, you just have 2x minus 3 is equal to 0. Plus and minus 0 doesn't make sense, so it's just 0. Move 3 over, 2x is equal to 3. Divide by 2, x is equal to 3 over 2. Okay, so we saw in this video, right, we have a lot of factoring skills in our arsenal, right? We know how to do guess and check. You could do the diamond method, right? We have special forms. We have greatest common factor. We didn't do anything by grouping, but there's always a possibility that you could do that as well. So, but again, keep in mind, in order to solve polynomial equations, you need a product equal to 0, right now at least. All right? We'll get more practice with this in class together.